This is two examples of a kmap optimization. So first one, given list of min terms. First, we construct a kmap. So let me choose the color of the pen, black. So here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So once we construct the kmap, next step is to find all prime implicants. So let's mark prime implicant. So four corners is a prime implicant. And the expression for this is so horizontally, since y value changes but z remains, but vertically w changes, x does not change. So x naught and z naught is expression for four corners. And then we have another pi in this whole column, and the expression for this is y and z. And then another prime implicant is the 4 in the center. The expression for this is vertically x do not change, horizontally z do not change. So xz is the expression for that. And then there is another prime implicant which is sometimes you missed to see that. So that is here we have a 2, and then here we have another 2. So that is a prime implicant. Prime implicant is a group which is not a proper subset. So these 4 together, there's no any larger group which completely includes these 4. So this is a prime implicant as well. And the expression for this is vertically w changes, but x does not change, but 0 value. So horizontally y do not change, but z changes. So this is a expression for that prime implicant. So once we identify all prime implicants, next step is identify essential prime implicant. Essential prime implicant is the prime implicant which has at least one cell that is not shared with any other prime implicant. So four corners those two are shared by other prime implicants, but those two are not shared by any other. So the four corner is essential prime implicant. And the one in the center, and these two are not shared by any other prime implicant. So this is a essential prime implicant as well. But the one in this column, none of the cell is uniquely owned by that alone. So each of those are shared by 2 or more prime implicants. So the one in this column is not a prime implicant, essential prime implicant. And then marked as red, these two and these two together, those are 4 cells. Also, each of those cell is shared by other prime implicant. So this is not essential prime implicant. So we have find 2 essential prime implicants. Once we have that, the next step is derive the simplified equation. So the procedure is that first include all essential prime implicants. So we have xz and then x naught z naught. That's all essential prime implicants. Using this prime implicants, let me change color to green. So with this essential prime implicants, we have covered this cell and this cell four corner. So this one and this one is covered by this essential prime implicant, and these minterms cells are covered by another essential prime implicant. Here, to complete the equation for function f, all we need to do is to cover the remaining two minterms not covered by essential prime implicant yet. So the next step is choose from non-essential prime implicants to cover the remaining minterms. Here the goal is simplification, so try to cover the remaining minterms with a larger, if possible, with a larger prime implicant. At the same time, minimal number of terms, minimal number of prime implicants to add. So to cover the remaining two, we can use this non-essential prime implicant, or at the same time the one marked as red. The one in this column, the one marked in red, is the same size with the 4 cells. So, and then we can have only one PI to cover the remaining two. So either you choose this column or either you choose the red one. It's the same complexity. So in this case, we have two optimum solutions. So first choice is if I choose the one in the column, then that is YZ. This is a simplified equation. Or if we choose essential ones, the marked as a red one, that is also the same complexity with this one. So we have two optimum solutions in this case. Here is another example. Let me change the color of the pen to black and then construct a kmap. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we constructed a kmap. So next step is find all prime implicants. So let me use blue. So let's find all prime implicants. So we cannot have any prime implicants with the 4 cells, so 2 cells. Let's begin with 2 cells. So these 2 is a prime implicant. Expression for this one is x changes, but w is not changing. So w is not changing with the 1 value, and then y and z are both the 0 value. So that's the expression for this one. So another prime implicant is with these 2. It's prime implicant. And also these 2 is a prime implicant, and these 2 is a prime implicant. And also these 2 is a prime implicant. Here is another prime implicant. And then we have another prime implicant by this grouping. And then here's one more. You may miss to find it, but here is another prime implicant this way. So we have identified all prime implicants. So next step is identify essential prime implicant. Essential prime implicant, the prime implicant should have at least one cell not shared by other prime implicants. But as you can see, so all the cells are shared by 2 prime implicants. So we don't have any essential prime implicants in this case. If we don't have any essential prime implicants, the next step is start with the largest prime implicant and then try to cover all minterms with a minimal number of prime implicants simultaneously. Try to have as large prime implicant as possible. In this case, all the sizes of all prime implicants are the same, so we don't have any choice for bigger one. So here is then the goal is use as less prime implicant as possible to cover all the minterms. So let's try first choose any pi which is largest, but size are all the same. So let me begin with this guy. So I choose this pi. The goal is to cover all minterms with a minimum number of pi's. So if I choose this one, I don't have to choose this one because there is a overlap and waste. So I will choose this one, and then I will choose this one, and then I will choose this one. Then I have covered all minterms. So by doing O-ring of those all red ones, it's one solution. So one solution is O-ring of all those red ones. And then we can find another solution. So let me change the color of the pen. Instead of starting with this one, if I start with this way, then next choice is this pi, and then next choice is this pi, and then next choice is this pi. By doing this, we cover all minterms, and then the number of pi's we use is identical with the red ones. So we have two solutions. All those green ones ordered together is another simplified solution for this function. So with these two, to find the simplified solution, first step is construct the kmap. Second step is identify all prime implicants. Third step, identify essential ones among prime implicants. And then the last step is to find the equation. First, include all essential prime implicants. If that's not sufficient to cover all minterms in the kmap, then now choose non-essential prime implicants, the largest one first. At the same time, try to have the minimal number of additional pi's to cover all minterms.